Good morning, everyone. My name is Aditya from BSC Chemistry Honors Final Year. Today, I am here to give a presentation on the topic mass spectrometry. My roll number is 1221271090016, and my topic is mass spectrometry. I will tell about what is mass spectrometry, their characteristics, about even electron Stephen's rule, ortho effect, and about the what are molecular ion peak and base peaks. Now let's start with the branch name, that is mass spectrometry. It is that branch of the chemistry which deals with the generation of the electrons from the molecule and the separation of the ions and molecules from their masses. Now we will see what is fragment ion. Fragment ion is the ion that is formed by the heterolytic or homolytic cleavage in a molecule ion by the using the remaining energy of the electron beam. Now let's see what is the mass spectrum. The two-dimensional graph which is a plot between the m by z of the positively charged ion and the relative absorbance or transmittant on the y-axis is known as mass spectrum. Now let's see what are the characteristics of the mass spectrum. Now first of all we will see what is molecular ion peak. It is the ion whose m by z value is maximum in the mass spectrum, and this peak is known as molecular ion peak, and it tells about the molecular ion of the sample compound. Now see what is the fragment ion peak. It is the ion whose m by z value is less than the molecular ion peak in the mass spectra, and it tells about helping in the structure determination of the sample compound. Now let's see what is intensity. The height of the signals when the directly reflects the abundance of the ionic species of the that respective m by z ratio. Now see what is relative intensity. The intensity of a given say peak with respect to the intensity is known as its relative intensity. Now see what is the base peak. It is the ion whose intensity, that is the relative abundance, is highest in the mass spectra. The intensity of base peak is assumed as 100%. With the reference of the base peak, we see other spectra of the molecule, other molecule spectra of the molecule. Now see what are the isotope peaks. The low intensity peaks with m by z, m plus 1 and m plus 2, along with the high intensity peak with the m by z m. It means that let's understand it with example. As the deuterium, whose abundance is 0.02% in nature, and in carbon with number of protons 13 having the abundance 1.1%, having the low abundance in nature. So the molecule containing the deuterium and the carbon having the 13 protons in its structure, then we will get frequently a number of n plus 1 peaks. These peaks are referred to as the isotopic peaks. Now see what is the even electron rule. It is stated as the successive loss of the radicals from its molecular ion is forbidden. Now understand this meaning with the help of an example. For this we will see the fragmentation pattern in the alkene. Now take an alkene, say an pentane, in which the electron beam is ejected, from where we will get a molecular ion and a free radical. From that, now the reaction will the cleavage will occur at that point where the maximum number of protons are present in the reference to the total number of molecules. Also, the even electron rule can be stated as 1. The even electron fragment ion is formed by the loss of the free radical molecular ion, then the fragment ion thus formed subsequent losses of the neutral molecule to give the another even fragment ion. Now let's see what is the Stephenson's rule. It stated as during the fragmentation of a branched alkane, the fragmentation occurs at the branching point, and the base peak will be the dead fragment ion, which is formed by the largest radical from the molecular ion. Here, the meaning of the statement is we will take any compound and the mass spectrometry is performed, then the first attack will be act at that point where the maximum branching occurs in the formula. Then the free radical ion and the carbocation will formed respectively. Now, let's see something about the McLafferty arrangement. It is a phenomena in which the rearrangement of gamma hydrogen atom occurs with respect to the multiple bond taking place with the beta cleavage of a bond to form a cation radical and a neutral molecule called the McLafferty arrangement. मीनिंग ऑफ द स्टेटमेंट इज कि मतलब किसी भी कंपाउंड में जो गामा पोजीशन होती है उस पर अटैक होता है, जिसकी वजह से हमें एक कैटायन मिलता है और एक न्यूट्रल मॉलिक्यूल मिलता है. इसके लिए हम कोई भी एक मॉलिक्यूल लेंगे, उसके ऊपर इजेक्शन करवाएंगे तो एक ऐसा मॉलिक्यूल बनेगा और बीटा क्लीवेज हो जाएगी, जिससे कि हमें एक कार्बोकैटायन मिलेगा और एक न्यूट्रल मॉलिक्यूल मिलेगा. नाउ लेट्स सी समथिंग अबाउट द ऑर्थो इफेक्ट. It is the effect that plays at the ortho position in a compound in which the ortho substituent has a alpha hydrogen atom. The main mandatory condition for this rule is that there must be a alpha hydrogen atom present at the ortho position. This effect is also used in differentiating between the ortho isomer from the para or meta isomer, or also it differentiate between the cis and trans isomers. For this we have taken to understand a salicylic acid and an electron beam is ejected on it, from which we will get a molecular ion and then a fragment ion, after which we can compare their base and fragment ion peaks to get the accurate results. Now see what is the nitrogen rule. It is only applicable on the compounds containing no or even number of nitrogen atoms that are 0, 2 or 4, etc. On ionization with the electron beam will have to give a monoisotropic molecular ion at even m by z value and vice versa. It is the statement. Now for this we have taken an example named as ethyl nitrile, on which the electron beam is acted, and we will get a value at m by z at 45 and a carbocation that is NH2 positive. Now see our last topic of our today's class, that is what is base peak and molecular ion peak in detail. In the mass spectrometry, the terms base peak or parent peak, or it is also known as molecular ion peak, refers to the specific features in the mass spectrum that provide the information about the sample being analyzed. Now, first of all, we will see what is base peak. In base peak, is the most intense peak or the most broad peak that we see in the mass spectrum, means it has the highest abundance or the intensity. These peaks represent the most common fragment ion produces during the ionization and fragmentation of sample. Means its abundance in the compound is most and the intensity of the base peak is 100%. With these, all relative intensity of the other peaks are measured. Now let's see about parent peak, or which is known as molecular ion peak. The peak is corresponding to ion that represent the entire molecule with the fragmentation. It indicates the molecular weight of the original molecule and is critical for determining the molecular formula of the compound. The intensity of a parent peak can vary and is not necessary to be the highest in the spectrum, but about the base peak, it is always the maximum one. The molecular ion peak is more intense than due to their fragmentation process. Thank you. In this video we have covered that what is mass spectrometry, about their definitions, their characteristics and some rules. Example, McLafferty arrangement, even electron rule, Stefan's rule, nitrogen rule, and a briefly discussion about the base peak and a molecular ion peak. Thank you.